We will start the part 2 for chapter 4. For the last few weeks, for part 1, we have learned about the theoretical part of number theory. So now is the application of number theory. So normally we will use this number theory for the process of writing the code. Okay. So we have some process which is encoding and decoding. Decoding is the opposite process of encoding. Okay. Okay, so some of the basic unit information we have a message, the finite sequence of character, and the words. Words is the sequence of 0 or 1. Okay, and the weight is number ones in the words X. It's called a weight of X. For example, when we have this X 11000, so the weight will be 2 because there are two number 1 in this word. So let's try this. Okay, what is the word weight of each of the given words? So here number A will be 2, 3, 2, 3, 5 and 4. Right? Okay, you get it right? So how are you after the midterm break? Are you okay? Or still in the holiday mood? Okay, okay, good. So where is others? Right now we have 32 online. Okay. Next will be the parity check code. So parity check code basically a simple error detection code. Okay, that adds an extra bit to a data word. Okay, it will add to detect the error. Okay, so it will add 1 or 0 to the last binary words as a word code. Okay, for example, let's say you have uh, okay, you have some words. Okay, 101, right? So these are the words. Then it should be an for odd parity and even parity. So for this word to be odd parity, so you know the weight of this word. Okay, let's write down several example. So it will be 0, 0, 1, 1, 1, 1. And another one should be 1, 0, 0, 0, 0, 0. Okay. So the weight of each of these 1, 2, 3, 4. So it should be 4. And then this one also 4. And this one 1. Right? The weight of each of this word. So the odd parity will be this one is even. Okay. If it is even, then you have to add 0. Okay. And to make it a odd parity. Sorry. Okay, add 1 to make it odd and 0 to make it even. Okay, so this one you have to add 1 for it to become odd and add 0 to make it a even. So in this case, the weight will become 5, right? And this 4. Okay, you just add to the last part of the words. Okay, at the last, but as a last binary words. Okay, so this will become 1 1 1 0 1 1 0 1. Okay, and here 1 0 1 1 0 1. Okay, so you add 1 to make it odd for the weight of even, and you add 0 to remain even. Okay, for the even parity. So similarly, for the second word, okay, you have to add 1 and 0. So it will become okay. So here 5 and 4. Okay, how about the third one? Okay, this is 1. Okay, the weight is 1, so it is odd. To make it odd, you just add 0. Okay, 0 to the last part and add 1 to make it even. Okay. So it will become odd and even. Okay, this is a very simple uh, error detection, right? But the parity check code have some limitation, which it can only detect a single error and it cannot correct the errors. Okay. Okay, so for this one, how about this? So it depends whether you want it to be even or odd. Okay, just like this example. Okay, next for Hamming distance. Okay, any question for the previous part? No? Okay, good. Okay, next for Hamming distance. Hamming distance is the weight difference or distance between x and y, where the number of position in which x and y is differ. Okay. Okay. So this Hamming distance is the length of two strings that are equal. Okay, it must be equal in equal value. Okay. For example, if you have string 1, okay, string 1 and string 2, okay, let's say the for string 1 the word will be 10110. Okay, 10110, and for string 2 11101. 11101. Okay, so look at the difference. Okay, calculated. So this having distance is calculated by counting the number of position at which the corresponding symbol are different. Okay, look at the differences. Okay, so we have 1, 2, and 3. Okay, so here the having distance is 3, right? Okay. The having distance is 3 as there are 3 positions where the bits differ. Right? So the having distance uh, S1 for string 1 and string 2, or just write it as having distance. Okay, having distance is 3. Okay, for this case. Okay. Okay, let's try this example. Okay, number 1. Okay, so you have, okay, for number 1, the first word will be 110. Okay, 110, 110. Okay, and the second code will be 000 101. Okay, so you know that for having distance, you need to have the two string that have the equal length. Okay, so these two have two equal length, and then you need to find the having distance by calculated the number of position at which the corresponding symbol are different. So look at the differences. One, two, three, 4. Okay. So the having distance between x and y. So let's say the first will be x and the second y. So the having distance between x and y, or the x or uh, position, is equal to 4. Okay. So how about number 2? Okay, look at number 2. Number 2, you have 01011 and 11001. Okay. So look at the different 1, 2. So the having distance between x and y is equal to 2. Okay, try another one. Number 3, 110010, and y 100001. Okay, look at the difference. 1, 2, 3. So the having distance between x and y is equal to 3. Okay, 4, 2, 3. Okay, so is it okay? No problem. Okay, let's move to the next subtopic, which is the minimum distance. Oh, minimum distance. Okay. So the minimum distance between all distinct pairs of chord word. Okay. So in other words, you can say that the minimum distance is the distance between any closest chord words, or the smallest distance between any pair of chord words in a code. Okay. The so an MN encoding function KF from BM to BN can detect errors K if and only if the minimum distance is greater or equal to K plus 1. Okay. Okay. So from this expression, you can say that the minimum Hamming distance between any two of its code words is at least K plus 1. Okay. Okay, look at this example. Find the minimum distance for the following code words. Okay, so what should we do? First, you need to identify the possible combination of code words. Okay, so you have 4 code words, right? 1, 2, 3, 4. So you have to pair it. Okay, first and the second. Okay, first and the third. Okay, let's write this as A, B, C, D. Okay, let it as A, B, C, D. Okay, so first step is to identify the possible combination of code words. Okay, so you have 4 code words and you want to combine it into pairs, which is 2. So you can use 4C2, you will get 6 combination, where the combination will be uh, A, B, and then A, C, A, D, B, C, B, D, and C, D. Okay, this is the combination of this. So, AB, AC, AD, BC, BD, and AD. Okay. Okay, there will be 6 combination. Okay, next step is to find the Hamming distance between them. Okay, so you have A, B, then A, C, A, D, B, C, B, D, and the last one C, D. Okay, so you check by yourself having distance between A and B. 1, 2, 3, right? You will get 3. Okay, can you find by yourself what is the answer? A, B. Between A, B, the distance will be 3. A, C, What is the distance between AC? Three, right? Is it correct? Three? Okay, three. And then A and D. Okay. A and D. A and D will be 5. Okay, dapat tak? Did you get the answer? Oh, okay, okay. Ada yang respons. Takut saya kalau tak dapat ni. Senyap je semua. Okay, BC. Okay, 2. BD 2. And CD also 2. Okay. So next, what is the smallest distance? Okay. The question asks you minimum distance. So what is the minimum distance? The answer will be 2. Okay. Okay, so the next question will be how many errors will F detect? So maximum number of detectable errors will be the minimum distance minus 1, right? Here. Okay, here. So from this, you know that the minimum distance equal k plus 1. So k is the detect errors. K will be the minimum having distance minus 1. So the mean minus 1 will be 2 minus 1. The errors that F will detect will be 1. Okay. So this one. Hmm. Okay, so for this group code, I think you can skip this. Okay, we move to the last part, which is the decoding. Decoding. So decoding is the process of translating received message into transmitted code words of a given code. Okay. So the decoding function must be onto. Do you still remember what is the definition of onto that we have learned in chapter 3? The function is one to one and onto. So what is onto? Onto means that each element in the codomain is an image of the domain. Okay. Or the all element in the uh right side are mapped from left. Okay. Say you have here A B C 1 2 3. So all these are mapped. Okay. All are mapped from the left, from the domain. So in this case, this function are one to one and onto, right? One to one and onto. If you have, uh, let's say you have, okay, 4. And 4 is not mapped from the domain. So this is not onto, right? This is one to one, but not onto, right? I hope you still remember. So decoding function must be onto so that every received word can be decoded to give a word in BM. So when you encode just now, function from BM to BN. Okay, BM will be in the left side. M left side and N at the right side. So now when you decode it, it will be the inverse process of it, right? So BM to N just now, then inverse it, you get N to M. Okay. So we will use the maximum likelihood techniques to decode this. Okay. And the step will be, first you need to determine all left cosets of N, and then find the leader coset, word of least weight. Okay, so normally the leader coset will be given in the question. Okay, and then find the number of leader coset. Next, when the word X is received, determine the coset of N to which X belong. And then let alpha be a coset leader. Compute the XOR of X and the alpha. Okay, don't worry. Okay, we will move to the example later after this. So first rule to find the leader coset. Okay, the first leader coset must be an identity. Identity all zero. Okay, arrange from identity and follow the next LC to increase than previous until the last is start from 1. Okay, cannot be the same with decode. Okay, these are some of the rule to find the leader coset. But if the leader coset is already given in the question, then you have to use the given value. Okay. Okay, now look at this example. Okay. Given f b2 to b4 with encoding function. Okay, this is the 2 codes and this is the 4 code. Decode 0111 and 1100. Okay, decode this. Okay, first this is your n. Your n is the value here. 0000, 1011, 0100, and 1111. Okay. Then if the coset leader is not given, then you have to identify the number of coset leader. Okay. 2 power of n divided by 2 power of m. Okay. So n and m. This is your n and this is your m. Okay. So 2 power of 4 divided by 2 squared, you will get 2 squared, 2 squared equal to 4. So your coset leader will be 4. So it's given here, mainly coset leader use will be 0, 0, 0, 0, the identity, and then you can increase it, and the last coset leader must start from 1, 1, 0, 0, 0. Okay. So how to write it? Okay, this is the uh, XOR for the decode. Okay, so LC XOR with the N. Okay, this is the given N, the given words, right? And then this is the coset leader. Okay, so you just find the distance between these two, Okay, so here no difference, so you get 0, 0, 0, 0. Here between these two there will be one difference, so it will become 0, 0, 1, 0, and so on. Okay, fill in your table for the XOR operation. Okay, so next, okay, when you finish fill in this table, okay, the question asks you to decode 0, 1, 1, 1 and 1, 1, 0, 0. So let's find in this whether it has the value of 0, 1, 1, 1 and 1, 1, 0, 0. Okay, so 0, 1, 1, 1 you have 1 and 2. So 0, 1, 1, 1, the decoding value of 0, 1, 1, 1 will be 0, 1 and 1, 1. 0, 1 and 1, 1. Okay, and the other one, 1, 1, 0, 0, 1, 1, 0, 0, the value of decoding function will be 0, 1 and 1, 1. Okay, very simple and easy. Okay, let's try one example. Okay, consider the 2 for group encoding function. Okay, decode the following function words relative to the maximum likelihood decoding function. Okay, decode A 0011 and B 1011. Okay, given the coset leader, the given coset leader will be 0000, 0010, 0100 and 1000. Okay. Okay, change the value. So you get this right? 0000, 0010, 0100 and 1000. So this is your coset leader. So you will get the value. Write down the value between this and this. So you will get the distance between it will be 1, 1, 1, 1. Okay, then 0, 0, 0, 1 and 0, 1, 1, 1. And then the distance between this value and this word will be 0, 0, 1, 1, 1, 1, 0, 1 and 1, 0, 1, 1. Okay, and another one, this and this, the distance will be 1, 1. Is it true? 0, 1, 0, 1, 1, 0, 1, 1 and 1, 1, 0, 1. Okay, you get the same answer?
Madam, how to calculate the distance?
The distance, okay, for example, you have this and this, right? These two. So 0, 1, 1, 1 and 0, 0, 1, 0. So you just find the difference. So here the difference will be 1 and 2. So when difference, it will give you the 1 value. Okay, so it will become 0, 1, 0, 1, 0, 1. Okay, so that's how we get this value. When it difference, it will give you 1. When it is same, it will give you 0. Okay?
Okay, okay, thank you.
Okay. Okay, so now you need to decode the value of 0, 0, 1, 1. Okay, decode 0, 0, 1, 1 and 1, 0, 1, 1. Okay, so let's find the value 0, 0, 1, 1. Find it from the table. 0, 0, 1, 1. Here, only one, right? 0, 0, 1, 1. So the value will be 0, 1. Okay, here. And next, 1, 0, 1, 1. 1, 0, 1, 1. 1 and 2. Okay. So your answer will be 1, 0 and 1, 1. Okay, so we just finished chapter 4.